observed that when the local velocity of air within a streamline, let's say, is high, local surface pressure is low. And he pictured the pressure being the result of molecules interacting with the surface. And to be honest, that is actually what the pressure is. It comes from molecular interactions with the surface. But the full equation includes a pressure energy term, so that a pressure energy term, a kinetic energy term, so the pressure plus the kinetic energy plus any potential energy coming from taking a body and moving it up or moving it down, will be equal along a streamline. And so any 2 points along your streamline, you'll be able to equate those two equations. And typically what we will do is we will assume that the gravitational part is negligible. In other words, we're not dramatically changing height between 2 points on our streamline. And therefore, the kinetic and pressure energy have to be exchanged, let's say. And in a way, so how do you get a feel for this? The way I got the way that gave me the best feel for this is if I think of the molecules being, when you accelerate them, let's say you squeeze them through a Venturi tube, you are interacting with a huge number of molecules. And by the time you're in the middle of your little choke point on your Venturi tube, you have realigned the molecules. So more of them are going in a forward direction and less of them are bouncing up and down. And so if you were to put a tube in pointing forward, you would get extremely high pressure. But because the surface is not acting in that direction, the surface pressure is lower because you've got less molecules actually hitting the surface.